So number 9, we're going to begin with step 1, which is to find the vertex. Everybody please write down the word vertex. Also write down the coordinate, because after all, a vertex is a coordinate. And also write down the formula for the vertex. X equals negative b over 2 times a. And let's rewrite that formula, but with parentheses instead of the letters. X equals negative parenthesis over 2 times parenthesis. Then after that, we go to the equation itself to identify the a, the b, and the c. The a value is 1, the b value is negative 2, and the c value is negative 8, which we're not even going to use right now. So let's plug in our b value of negative 2 into the parenthesis, plug in the a value of 1. The minus minus, change to plus plus. Why is that? Because a negative times a negative equals a positive. So we end up with x equals positive 2 over positive 2, which equals 1. So the x value of the vertex is 1. If I want the y value, I simply plug it in. So over here on the side, I'm going to rewrite my equation, but with parentheses instead of the x's. And inside of those parentheses, we are plugging in that vertex x value of 1. And when we do this math, we have to follow PEMDAS, the correct order of operations. So we're going to begin with parentheses, but there's nothing to do inside the parentheses. So we move on to e exponents. So we have 1 squared, that is 1. And then we're going to bring down everything else. We're going to bring down the minus 2 times 1 and also the minus 8. So after exponents is multiplication. If you went minus 2 times 1, that is negative 2. Bring down the minus 8, bring down the 1. And if you do 1 minus 2 minus 8, we end up with minus 9.
Yes.
So the vertex is minus 9. So the vertex is 1, negative 9. Let's graph that most important point of 1, negative 9 and put a dot right there. Okay? Right through that vertex. The very next thing to do after you graph your vertex is to draw the axis of symmetry right through it. So I'm zooming in a bit. I'm going to do a dotted line vertically right through that vertex, all the way through the graph. Now, that green dotted line that's vertical, and any vertical line has the equation appearance of x equals a number. So if I asked you to state the axis of symmetry equation, you would simply say x equals 1, which is the x value of your vertex. So the axis of symmetry equation, the vertical line that goes through the vertex, is always going to be simply x equals the x value of your vertex, x equals 1. If your vertex was at 5, 2, then your axis of symmetry would be at x equals 5 right through it, right? If your vertex was at negative 9, 1, then your axis of symmetry would be x equals negative 9 right through it. So whatever your vertex x value is, your axis of symmetry equation will be x equals that value. Okay, so we have the most important point. We have the axis of symmetry. The axis of symmetry provides reflection for the coordinates. We're just missing some coordinates. So what do we do to get more coordinates?
You put a table.
XY table, that's right. Now, you could use a table, which is totally fine, or even faster, even better.
Since the a value is 1.
Since the a value is 1, because the a value is 1, we could use the pattern 1, 1, 2, 4, 3, 9. Okay? So what does that mean? We first need to understand that this parabola, does it open up or down according to A? It opens up. So this is technically our minimum point. Now, knowing that it opens up, we're going to use this pattern 1, 1, 2, 4, 3, 9. And the only reason we're able to use this pattern is because A equals 1, and here's the pattern 1, 1, 2, 4, 3, 9. So let's go to the vertex and go 1 over, 1 up, and let's put a dot right there. And then you go back to the vertex. The whole pattern, you got to keep going back to the vertex. The next one is 2 over, 4 up. So back to the vertex, go 1, 2 over, and 1, 2, 3, 4 up, and put a dot right there. And then we go back to the vertex for the last one, 3, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there. Are you with me?
Yes.
So we have the axis of symmetry. Let's just reflect it over to the other side of the axis of symmetry. So this one is 3 units away, so go 3 units away that way and put a dot right there. And this next one is 2 units away, so let's go 2 units away and put a dot right here. And the last one is 1 unit away, so let's go 1 unit away and put a dot right here. And we're done. All we have to do is draw our parabola. That doesn't look that good. Let me change the color of the parabola. I'll go with green, why not? So that is our parabola. We put some arrows on it because it continues, right? Now, if you wanted to, you could have used the XY table, but it's more work, right? And when you use the XY table, you have to be careful what values to use. For example, what's an easy number to plug in? What's the easiest? Okay, so if you wanted to, you could plug in a 0. And whenever you plug in a 0 into a standard form quadratic trinomial equation, the C value will be your output. 0 squared 0, 2 times 0 is 0. 0 minus 8 is minus 8. So 0, negative 8, that's the actual coordinate. And if you were to graph that coordinate from the origin, here's the origin, 0 on the x, negative 8 on the y, you get to that blue dot right there that we already have because of the pattern, right? So it's really longer to use an XY table. Not only that, 0, that was easy, but what would the next number to plug in be?
1.
Okay, now if you did plug in 1, you'll see that you're wasting time. You know why? Because we already plugged in a 1 to find our vertex. We got out a negative 9. So if you plug in a 1 again, you're going to get out a negative 9 again. So what other number to plug in?
Negative 1.
Now, if you plugged in a 2, that still would not be good because it would still give you the output of negative 8. It's weird, but so it's better to use the pattern. Now, if you did go negative 1, you'll be able to get extra values. So the pattern is best when your A value is 1. Does that make sense? Now, you could use the XY table. Like I said, you got to be careful with your math. You got to be careful with your inputs. Sometimes you plug in a number, you get the same output. It doesn't even help you because it's really just a reflection of it. Okay, it's really just a reflection of it sometimes. So the pattern is the best way to do it. Let's move on. Number 10, could you use the pattern 1, 1, 2, 4, 3, 9?
Yes.
Yeah? Okay. Shall we try it?
Yes.
What's the first step?
Right vertex.
Vertex. What is a vertex? It's a coordinate.
Yeah.
How do you find that coordinate? With x equals negative b over 2a. And use parentheses instead of the letters. And where do we get the numbers from? We go to the original and label the a, the b, and the c. Then we plug in into the parentheses. The b value is negative 4, the a value is negative 1. So a negative 4, that really changed to a plus 4. So you really have x equals positive 4 divided by negative 2, which means that x equals negative 2. So the vertex x value is negative 2. If you want the y value, what do? So we plug it in, and notice that I used parentheses instead of the x's, and now I'm going to safely plug in my negative 2 right in there. So let me zoom in so we can do this math correctly. Do not change this minus and this minus to plus plus. Do not. Why not? Because the whole changing of minus minus to plus plus, it comes from the rule that a negative times a negative is a positive. But what must we do before multiplying? Exponents. So we technically have to do this first, negative 2 squared, which is positive 4. And then we need to bring down the negative that's out there in the front. So that really becomes a negative 4. And then let's bring down the rest. We have a minus 4 times negative 2 minus 3 at the very end. Let's multiply next. The negative 4 times negative 2, that's positive 8. Bring down the minus 4 that's in front. Bring down the minus 3 that's at the back. And what is negative 4 plus 8 minus 3? Positive 1, right? So what did we find? We just found the y value of the vertex, which is 1. Now that is the most important point of the whole parabola. So let's go to the coordinate negative 2, 1. Negative 2 on the x from the origin, 1 on the y. There it is. We draw our axis of symmetry right through it. And if I wanted you to give me the equation of that vertical line, that green line, that axis of symmetry, what's the equation of that vertical line?
Going down.
No, I'm talking about the actual equation of that vertical line. X equals what?
Oh, -2.
X equals -2. Simply the X value of your vertex. And they will ask you that on future quizzes, tests, maybe even on the final. What's the axis of symmetry? It's the equation X equals -2. Okay, so we still need more coordinates. So you could use an XY table if you want, maybe if you're bored, right? But the quicker way of doing it is using the pattern 1, 1, 2, 4, 3, 9. So let me write that right here on the side. 1, 1, 2, 4, 3, 9. This pattern works for any equation that has an A value of 1.
Also, if it doesn't equal 1.
If it doesn't equal 1, you can't use this pattern. I'm going to show you in a moment or two how to force the pattern, but we have to modify the pattern. Okay? So right now, if the A value is 1, you could use 1, 1, 2, 4, 3, 9 from this vertex. Now, Adrian, is this opening up or down according to A?
Down.
Down. So you need to know that first. That way, when you go 1 over, you don't go 1 up. Because if you're going up, that means it's going to open up, right? But you just said it opens down because the A value is negative. So 1 over, 1 down. And let's put a dot right here. And then we go 2 over back to the vertex and go 2 over, 4 down. So back to the vertex, 2 over, 1, 2, 3, 4 down, and put a dot right here. And last but not least, 3, 9, back to the vertex, 3 over, 1, 2, 3, 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there.
So if it's negative, it's going down.
We still need to map over the coordinates to the other side. So let's do that. Let's move this, that's 1 unit away, over here to one side, 1 unit away on the other side. And we have that coordinate there. We have 2 units away. We have 3 units away. And we're pretty much done. There is our perfect looking parabola. You know what? It doesn't look good in black. Let me change it to green. Now, there are a couple of things on these two that I just did on this video that I forgot to mention. And that's the domain and the range. Okay? So I've been explaining this on the other videos with other classes. But the domain are your X values. I hope we remember that from when we did functions, inputs and outputs. The inputs, we plugged them into the X's. The outputs were the answers, which were the Y values. So the domain are the inputs. So the domain are the X values. Now, let's think about this parabola right here. Does the parabola exist at the value 10, X value of 10? Does it exist at the X value of 10? It does, but way down here off the graph. Does that make sense?
Yeah.
Does it exist at -10? Yes, it does. It's just way down there off the graph, right? Or you could even think of it numerically. Can you plug in a 10 into the X's?
Yes.
Yeah, you could, right? So the input, it could be 10, right? The input could be -10. You could plug in a -10 into the X's if you want. You could even plug in a fraction. You could plug in a 1/2 or a decimal, a 0.75. The X's are the domain values. What could you plug in? You could plug in any number you want. So when they ask you for the domain, we say X equals all real numbers. That's right. Now the range is a different story. The range are your Y values. Now your Y values are not left and right. The Y values are up and down, right? The Y axis is vertical. It's up and down, okay? So does this parabola exist at the Y value of 1 at this level? Does it exist at the Y value of 1? Yes. Does it exist at the Y value of 0?
No.
Yeah, it's right here and here, right? Does it exist at the Y value of -10? Yeah, right here somewhere and right here somewhere, right? Does it exist at the Y value of 5? No. How about -2? No. So when I say the range, I want you to tell me all the Y values this graph exists at. So it's at this point and it's below. So what is this value of Y? The value of Y. Remember, here's the Y value of 0. This is a Y value of 1. And we said it's below 1. So how do we say that it's at 1 and below 1 in terms of an inequality? We say Y is less than or equal to 1. And that describes our range.
Why can't we just say like
One down.
So let me tell you this. Any parabola, doesn't matter if it opens up or down, it doesn't matter if it's wide or narrow, any parabola is always going to have the same domain. X equals all real numbers. Super easy, right? Any parabola is going to have the same domain. X equals all real numbers. Now the range, that's like, oh, is it above a certain value or below a certain value? That varies. You got to take a look at your graph, technically your vertex, and say that it's at that Y value vertex and below or above, depending on if it opens up or down. So we didn't do that for the previous one. Let's go back up here and let's practice domain and range here. So once again, the domain of this guy, what do we say for the domain? X equals all real numbers. It's the same answer for domain on any parabola. It doesn't matter if it's opening up, down, if it's wide, if it's narrow, if the A value is 1 or 7 or 1/3. It doesn't matter. The domain's always going to be X equals all real numbers. Now the range, the fun part, the range. Y is what? Let me just ask you this. You don't have to draw this line. I don't even want you to draw this line. But what is this Y value right here? What is the level?
Y is less than or greater than 1.
That's Y equals -9, right? That blue line?
Yeah.
Now we know that this parabola really does touch that Y value of -9. And is it above or below that Y value of -9?
Below.
It's above.
So it's greater than.
So Y is greater than or equal to -9. Okay? Y is greater than or equal to -9. These are very important details, guys, domain and range. So number 11, step 1, find the vertex. Use the formula. Remember that instead of the letters, put parentheses. Identify the A value of 1, the B value of -2, and the C value of -3, and plug in the B and the A into the formula. So you're going to have -2 for B inside the parentheses and 1 for A. Let's work it out. You're going to have a +2 over a +2. So X equals 2 over 2, which means that it equals 1. So the vertex X value is 1. And we're going to plug it into the original equation to find the Y value of the vertex. So there's my equation with parentheses. I'm plugging in the X value of 1. We're going to do exponents first. 1 squared is 1. -2 times 1 minus 3. So we really have a 1 minus 2, which is a -1, minus 3, which is a -4. So the vertex Y value is a -4. So on the graph, let's go graph that most important point called the vertex. 1 on the X, -1, 2, 3, 4 on the Y, and there it is, 1, -4. Let's also draw our axis of symmetry right through it. If they ask you for the equation of that axis of symmetry, you simply say X equals the same X value of your vertex, which is 1. Now, we definitely need more coordinates. Now, you could use an XY table, or what I like to use is the pattern 1, 1, 2, 4, 3, 9. You don't have to modify anything because the A value is 1, so we're just going to use this pattern from the vertex. Again, it's important that we say that we're using the pattern from the vertex. So we know that the A value is +1, which means it's opening up. So let's use the pattern from the vertex 1 over 1 up and put a dot right here. And then let's go back to the vertex and go 2 over 4 up. So check it out. From the vertex, 2 over 1, 2, 3, 4 up, and we're right there. And let's go back one more time to the vertex and do that last part of the pattern, 3 over 9 up. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And then, of course, we map them over to the other side, right there, and right there. And then just connect the dots. And ladies and gentlemen, we have our parabola. Let's just ask you a couple more questions about this parabola. What is the domain of this parabola? X equals all real numbers. How about the range? Y is what? Greater than or equal to the lowest Y value, right? What's that lowest Y value right here? That's -4. Okay, so Y is greater than or equal to -4. It's greater than or equal to because it's above that Y value of -4. If it were opening down, it would be less than or equal to because it's below.